Good morning, ladies and gentlemen.
Good morning.
We have a few announcements before we get to today's feature presentation. I'm going to start out with Jerry. He has a couple items of interest, and then I will follow up.
Hi there. Actually, it's only one item of interest, and it may not be of interest to everybody, but there's probably somebody out there that it might be interesting for. Mike Sasnet had a Porsche 914 that was converted to electric with the AC drive system from Selectria, and he donated it to Los Altos High School, and they had an auto tech program there where they were using the car as part of their training. I guess the auto tech program is sort of winding to a halt, and they've contacted Mike and asked him what should they do with the car. Would he like to have it back or whatever? One of the options was for that school to donate it to another school, so we don't know if that's going to go through yet or not, but in case it doesn't go through, the idea that I suggested to Mike was that he could donate it to the EAA, take a tax write-off like Google did when they donated the Sparrow to us, and then we let the highest bidder among our members buy the car from us. They get the title, pink slip, and DMV transfer and all that stuff, so they're the proud new owner of this Porsche 914 electric. And then we get the money that we use to help offset the ridiculously high fee that De Anza College charges us to have our car show there every year. So if you're interested, let me know, and put your name on the waiting list.
What kind of batteries?
I believe they're lead acid batteries, correct?
Sealed.
Yeah, maintenance free.
Maintenance free.
It doesn't exist.
Just replace them every year.
Yeah.
No maintenance. At twice the cost.
Brand new maintenance.
All right. The next thing I want to mention is that there is a car show coming up. I don't have the exact date, but I believe it's in July. It's the Hillsborough Concord d'Elegance, and they are looking for electric vehicles to put on display this year. So if you have something that is nice and historic, this is a upscale car show. If you have something that might fit in, or if you know somebody in that category, have them contact Kent or George or possibly myself. Like I said, I don't have all the details yet, but I will try and get them. Yes?
Yeah, I think it's July 15th.
Okay, July 15th.
I think that's what the email said.
Okay.
They need a Sparrow.
And for people who are displaying their vehicle, they are offering free admission and a couple other perks, I believe. I also wanted to mention that we are looking for speakers or topics for future meetings. We don't have anything lined up right now for July, so if you have any suggestions, see me after the meeting. Does anybody else want to make an announcement before we begin the course presentation? Oh, okay. Then today's speaker is Cor van der Water, and he actually has two topics for us today. One of them is how he took two used Nissan Leaf battery packs and installed them in his U.S. electric car pickup. And the other presentation is on how to convert a portable EVSE to operate off 240 volts. So, for those of you who don't know him, this is Cor, and I will give him the microphone.
Perfect, thank you. Thanks for the introduction. Yeah, so let me get started with let's see if the display comes up again. Did it turn off? All right, this might be a familiar sight for some of you. This is a Leaf battery pack. This is the first time actually that I saw the insides of a Leaf battery pack. This is in the parking lot of a dismantler near Sacramento. And I opened the pack to take the modules out. You see something like this, nice orange bars and a lot of voltage, so I was very careful until I got to the individual modules. You see that they are arranged positive, minus, positive, negative, alternating for the bus bars. And the reason that I took everything out of that pack is that it wouldn't fit in my vehicle otherwise, because I came to Sacramento by Prius, which is another story. That I arrived at the dismantler. They had never taken a leaf apart, so I over the phone had bought the battery pack and went there, and the yard guy came out and said, "Where is the battery pack?" I said, "Underneath." So he went back, and 5 minutes later came back and said, "I hope you brought a big truck." I said, "No, I'm here with Prius." But he was gracious enough to set it out, and that's why the first picture that you see is actually in the parking lot, where he set out the pack on a dolly, so I could work on it and take it out in their parking lot. They were cool with that. So that was my luck. This is a Nissan Leaf, where normally that battery pack that you see next to it is bolted underneath. A couple times in my garage I did the swap of a new battery into a Leaf, and of course you need to do something with the old pack, and I had already bought an old pack from the dismantler, and somebody donated to me a US electric car with, of course, in need of batteries, because the lead acid pack had been sitting there for many, many years, and so it was dead. I tried reviving it to move the vehicle around, and it wouldn't even take enough charge to just more than just shudder a little bit and then die. So I removed that pack and decided that the Nissan Leaf batteries that I had sitting was the way to go. Only how to fit them in. Somebody on the East Coast actually gave me the idea, because he had fitted one Leaf pack into his truck and reported happily that he could reprogram the controller to take the different voltage, because standard is 312 volt, but the controller in the US electric car actually takes up to 405 volt. The internal components are 450, and they do a 10% derating, so that's the 405 volt that they allow on that controller. So that it fits perfect with the Leaf pack that goes up to about 395 volts max. So I decided to start to measure things and to see if I could shoehorn 2 packs in, because that would give me over 100 miles of range, which would make this a very useful vehicle for me. And so I started bolting batteries together in a slightly different configuration than I had before. Here you see one side of the battery pack. I don't have the oversight of the US electric car truck. Imagine that the cabin is on your right. What you see in the top of the page is the area above the drive shaft that goes to the rear axle that is here on the left, invisible. And this is the right side battery box that actually extends slightly underneath the cab. And the same is replicated on the other side of the drive shaft. So I built a pack that had 3 stacks of batteries, 4 high modules that could exactly shove under the cabin, and then I had the rest of the box available, and you see that in a second.
Is that box original?
That is the OEM US electric car box that was installed in 1994.
So presumably it's structurally already crash-worthy and normal?
It is designed like a tank. I've drilled through it a couple times to install new wires, and I think it is a 1/4 inch aluminum 6061, if I'm not mistaken. So it's a tank. It's designed for about 1,600 pounds of lead acid.
Right.
And yeah, I'm fitting it here with the 2 leaf packs. Each leaf pack, the modules by themselves weigh about 600 pounds. The total leaf pack, including enclosure, is about 800 pounds. But it has a double wall steel enclosure. So about 600 pounds of actual modules. So I have about 1,200 pounds of lithium in that box instead of the 1,600 or 1,800 pounds of lead that used to be in there. Okay, so I think I have a later picture, but one of the things, if you reconfigure the pack, one of the most interesting things that you encounter is actually the bus bars, because of course you need to reconfigure those to preserve the order of the wiring, so that the voltage on the BMS stays the same, but you need to configure them in a different order. So you end up with things like this, cut pieces of the bus bar. But everything fits pretty neatly. Also sliding it, you see a picture here where the perspective is, you look under the cabin from inside the battery box, so that's where it is going to slide into, and then it disappears under there. I have a little, I don't know if it's visible, a little standoff to the side, because I didn't want the bus bar to be crushed against the side of the box. So I bolted down little tabs to the side that stuck out a little bit more than the bus bars, so that would scrape along the side of the battery box as I slid them in, but would prevent the bus bars to crush against the aluminum side of the box. I didn't want the short circuits in there. Overrides, I believe I call them. Here is the first of the short packs slid under there with the 2 wires coming out. BMS wire is also some in there. The BMS wire is original from Nissan, so I could still use the OEM Nissan BMS. That was something else that I found out. The Nissan BMS is actually almost completely independent from the vehicle. As long as it sees all its cells, all 96 series cells, and you apply 12-volt battery to it, it will happily balance and go ahead and keep the battery in good shape without any external influence. You can connect the CAN bus and monitor it, but it's not necessary for it to actually work and balance. So that was a very good find. Here you see of the remaining 4 stacks, 2 already installed, but on the far right, sticking out from under the cabin, the last of the 3 that was slid under there.
So these are vertical then?
And these are sitting with the terminals up, yes. And this is a little bit dark picture, sorry, it was taken late at night in my garage. With all the 4 stacks in there with the terminals up, and of course the next thing is to start using the bus bars. You see the long stack of bus bars that normally goes across the half pack sitting here loose, already mounted. One of the quarter pack stacks, the other one is already disappeared under the cabin. So then you get this also in a cut and paste type action, and a lot of electrical tape to put everything back together. By the way, if you need electrical tape, I just happened to find a moving box full of tape at my former employer, so feel free to grab some tape if you want. Tape is free, at least today. So yeah, lots of tape, as I mentioned, to protect all the BMS wiring, to put everything back in place. And here it starts coming together. This is the left side battery box in the bottom. You can see that already stack was shoved under the cabin, and the first of the two, the first two of the four stacks already dropped in the back. And this is an overview of everything in place. Just need to put the covers on the bus bars on the left pack.
Are these all the cells from the two original packs, and did you do any testing of the individual ones? I mean, were they in good shape when you got them, or?
I believe I measured the voltages. I didn't have much other to do. I did notice that when you keep the original BMS, the BMS actually estimates the amount of capacity in a pack. It during charge and discharge, it will from the change in voltage and the current that it measures with its current sensor, it will actually try to estimate the capacity, and so it will adjust the capacity over time. That's why in this on Leaf, with Leaf Spy, you can see how much that it degrades over time. And so that was the measurement that I had, because I had the two original BMSs still marked. And both packs are actually pretty good. I have the original BMSs still in the car, because I use that to balance each of the individual packs, because only the end plus and minus terminal are connected in parallel. All the cells in between are managed by the BMS only. So the two BMSs report the same pack voltage, but they report individual cells at different states of charge. Both packs were degraded, so I started off not with the full range that I could have had, but I found a good source for essentially second life batteries. Used lithium pack that each was about 70-75% state of health at the moment that I installed them. And I've done almost 10,000 miles now and not noticed much degradation over that period of time. Whereas I did have a US electric car before in 2005 that I installed a lead acid pack in, even more than fit in the bed itself. In the original box I had to mount an extra box behind it, because originally it was designed for 80 amp hour of pack capacity, and I put in 110 amp hour of total pack capacity. And that gave me a maximum of 10,000 miles, and then the range was diminished to about 10 miles. So yeah, having about 100 miles of range now is really so good. And my neighbors agree. Here you see the current sensor. The one that's plugged in is actually the original sensor. It's hard to see, but it is sitting on one of the bus bars that goes across two cells, two modules. On the right, you see a very similar current sensor. Apparently, they like to reuse, and that's the one that sits on the auxiliary battery. So the leaf actually tells you how much current that you're drawing or putting into the auxiliary battery. And I've seen that go over 100 amps if I let the 12-volt battery die off for a while, running something while the car is running. That as soon as you start the car, it will actually do about 100 amps into that auxiliary battery.
That's 12 volts, right?
That's, yeah, but the current sensor doesn't care. Current sensor just measures current, whatever.
I was just asking what the size of the auxiliary battery was.
Oh, the auxiliary battery in the Leaf is pretty small. I think something like 40 amp hours.
Yeah.
Oh yeah, this is looking into the. Look, so here we have the two original BMSs. This is the highest capacity. It estimated at 52 amp hour left, and the worst one was 46 amp hour left in the pack.
Now, was that based on the minimum cell, performing cell, or is it an average?
I don't know how the BMS does its work. Yeah, I mean, I know that he tries to balance, and he just estimates what the capacity of the pack is. Yeah, no doubt that it takes into account the lowest cell, because it always limits the pack to what the lowest cell is doing. I've seen the BMS, especially when fast charging, you see all the cell voltages come up if you monitor it with the leaf spy, and as soon as the first cell hits 4.12 volts, the throttling back starts. And so you can really see that this charging, child mode charging, is constant current, constant voltage on the highest cell. That's how it charges.
Does that then bring up the other lower ones, or what about leveling? How does leveling still work in this system?
Oh, the BMS itself is interesting. The BMS does balancing 24/7. It's always running. And it has only 10 milliamps of balancing capability. So it can turn on an 430 ohm resistor across a cell, or not. That's all it does.
So it does that on the highest and the lowest ones to try to balance them, or?
As far as I've seen, it just constantly, whatever the state of charge is, it will constantly balance. Even when the pack is very low, it will occasionally switch on some of the balancers. Yeah.
Did you say 24/7 even when the car shut off in the garage?
As long as there is 12-volt battery, yes.
Okay.
Yeah.
Which is why the 12-volt dies if you let it sit for a long time.
Actually, I had problems with my 2013 Leaf, but it's a known defect that sometimes the computer doesn't shut down properly, and it remains running, and so overnight the 12-volt battery dies. When it does shut down properly, I've had no problem just letting the Leaf sit for a week or more. Yeah. But the BMS is actually pretty sparse with current consumption. Even its internal reference that it maintains, I believe it was spec'd for something like working on 1 microamp. So it's really designed to work very well. I was impressed with that. This is some of the other wiring. Let me see, why did I show this? Oh yeah, I remember now. This on the left side are the 2 contactors. Originally, the US electric car has each half of the battery box has its own string of 26 batteries for 312 volt each, and only when the car turns on are both connected in parallel, and that's why it has 2 contactors. The one wire to point out is the one to the very right that has a green, black, and white wire come out. And that's actually a wire that I added. I told you I drilled into the battery box. That is one wire that I run into my cab, where I have a mid-pack connection, and the 2 ends of the pack are connected. Those 3 wires. And the reason that I did that was to allow me the ability to connect an inverter, so that I can have AC power directly from the battery pack, because this 1994 truck doesn't have its own features to do that.
Wait, so that inverts to what?
It's currently only the DC connection to the pack,
On the high
and so I want to be able to plug in an inverter directly into the high voltage bus of the inverter, so I can generate 110 output. I have an inverter that runs off of another voltage, but the internal bus is 200 plus 200.
Where do you find that?
Let me see those. This is the other side. This is the plug that I marked with mid-pack plus or minus. Here, resistor that I added that has nothing to do with the pack, but everything with the car. The car monitors that the pack is insulated by measuring against mid-pack voltage. And I found out that the BMS has actually capacitors inside. that apparently have a weird way of charging or discharging upon making or breaking the voltage to the controller. So what I found out was that my controller was faulting his isolation test, not because of that the pack wasn't isolated, because it was poorly isolated. In fact, I installed it with my bare hands working with metal tools, so everything had to be isolated, or I would not be standing here. But the BMS apparently has some internal capacitance that upon turn on something happened, and I had to add a little resistor to mid-pack between frame, ground and mid-pack of the battery, just to keep the controller happy to convince its isolation tester that yes, it was still at mid-pack voltage. Just something weird that you can encounter when doing a pack. Oh yeah, the tires. I don't know if you see the pattern on the tires. Besides the normal thread, it also had some additional patterns that I think is some dry rot that I didn't like too much, so I replaced those with brand new tires just to get this vehicle on the road. And last month I bought a Nissan Leaf, and I wanted to park it at work because I needed a vehicle to test Chatamo charging. So my colleagues were amazed when I showed up with a US electric car, electric truck, with a tow dolly, with an electric vehicle on the dolly. So within 5 minutes it was posted on Facebook that this was the most futuristic thing that they had seen. So sometimes I carry another pack in the bag, so it's temporarily has 3 leaf packs, just to not to extend the range, but just to transport. As I said, it has great utility. Hey, what happened here? That's interesting. Folded. Okay, I have to see what we do here. Probably kill this guy. Put my glasses on so I can see. Let's see if it works. Yeah, it does work. Just have to with my hand.
Ken showed a similar picture of his Model X towing the RAV4.
Okay, yeah. Yeah, Model X has also very good towing capabilities. So here I'm actually robbing one pack that is sitting here in the back out of this Nissan Leaf that had received a brand new pack a year ago, and I needed a pack similar to the pack that you saw sitting in the back of my truck. But it was only available as installed in the Leaf, so I bought the whole Leaf. And I took the pack out and then mounted an older pack back in. Yeah. Let me see.
Wait, you took the new pack out of the used Leaf?
I needed a good pack for another project, so it only came with car.
Not the first time.
Yeah.
So that was an older Leaf that, what, a lease return that had already...
Oh yeah. This is a 2012 that the previous owner noticed that the range was limited, so he wanted a new range. So a year ago he put a new pack in, and now he's moving to the East Coast, so he was selling the vehicle. And so he had advertised, Nissan Leaf for sale with new pack.
He didn't pay for that new pack, did he?
He did. I bought it for less than he paid for the pack.
Good. That's what I told Nissan. I said the car's not worth the cost of the pack after you replace the pack. You proved my point.
Let me see, where are we? I actually wanted to show this picture.
Honda gave me $4,500 for a 2011 with 4 bars lost as a trade-in on a Clarity.
Ah, yes. This is the picture that happened yesterday. You see a US electric car and a friend standing next to his US electric car. and he needed it moved. And he just so happened to have tow bar hitch, what is it, the mounting on his front bumper.
On front.
And I had installed a 2-inch hitch on my truck, so we made a little train of 2 US electric cars being moved at the same time.
You couldn't just throw him a line to your high voltage bus after that?
That would have worked if his controller worked, so it's, yeah. That's why he needed it off the street, because he had received his third notice from the police that if he didn't move this vehicle now, it would very soon be towed. And not to a place he wanted.
No.
So, yeah. Yeah, that concludes the presentation about the Nissan Leaf packs inside.
Question?
Yeah, sure.
How much do these used leaf packs typically go for?
Ah, yes, very good question. Depends on the... Oh, yeah, the question is, how much does used Nissan Leaf packs normally go for? And that actually depends a lot on which year and what capacity is left. Well, usually the capacity you don't know, so that's a hit and miss. I have bought several packs from dismantlers. Some of local dismantlers, just somebody that received a vehicle in their yard and was taking it apart and posting it on Craigslist and buying the battery out of the vehicle essentially. But most packs actually from national chains like LKQ, but they want 2,700 or so for a 2015 pack. They usually tell you how much miles on the car, and if you find a significant difference or the pack is damaged or something is not okay, then you can return it. I mean that's the advantage of companies like LKQ. And I have done that when they, the pack was not worth the money that I paid for it.
Question,
Sure.
had you considered forced air cooling in your installation for a battery pack?
So the question is, had I considered forced air cooling in the battery pack? And I did consider that. In fact, my previous US electric car truck did have the setup, the ventilation openings for forced ventilation. Reason was that that truck was originally reconverted after being converted by US electric car. It was reconverted by a company called Wave Driver. It's a UK company that was doing high power inverters. And they were actually known for blowing up packs. They've even set fire to a lead acid pack. So yeah, you really need to. But they had a charging connector to that vehicle, which was 3-phase 80 amps. So that yeah, they could charge just like advanced or what is ACP was doing with charging through the motor windings. They actually had a big three-phase inductor sitting next to the inverter to be able to charge from a 3-phase at up to 80 amps. Yeah. So that pack had ventilation. I didn't set it up here. Reason was mostly that I've seen leaf packs do pretty well as long as they're not too hot in the Nissan Leaf, underneath the Nissan Leaf. Here it was actually 2 packs in parallel, so the current of each pack is half. I never draw more than 100 amps in each pack because the whole truck its original motor is 50 kilowatt, and the inverter can do up to 250 amps. So I typically see it top out somewhere between 60 to 80 kilowatt maximum at the increased voltage that it has from the Nissan Leaf pack. So it does about 200 amps maximum from the pack, about 100 amps per pack. I was not too worried about the temperature rise.
How do you charge the packs?
I am still using the original designed charger in the truck, which is the Dolphin controller charging through one motor winding into the pack, so it does a simple boost into the pack. I am still planning to install a CHAdeMO, so a direct DC interface on it, so that I can dump directly into the pack, but have not yet found the time to do it.
So to do that, you'll have to engage the contactors to parallel the packs to charge off of one CHAdeMO?
Actually, the two packs are permanently parallel at the moment. The two contactors are now in parallel. I only need one, but it was already in there. Yeah, I didn't need to do anything. The packs are in parallel. The only thing I need is to pull information from the two BMSs in order to find the highest cell in order to throttle back the charge. So that's the and of course to find the controller to do the CHAdeMO protocol.
Probably get one from Tony.
I might. I don't know. Yeah. Jerry.
How's your friend going to get his Dolphin controller repaired? Are there people that kind of still do that?
Okay, so the question is, how is my friend with the problem with his controller getting the controller repaired? That's why about 15 years ago or so I started a US Electric Car Yahoo group. So there are a few people active still in there, and there is one guy on the East Coast, Chris Eck, who is repairing Dolphin. So yeah, he's able to, and so my friend shipped his the board in his controller that failed over to him to get it repaired. Yeah, but that's, you know, with an older technology that's becoming more and more problematic.
Any idea what fails when those things fail?
The question is what fails on the controller. In this case, it was the charging board, which is a known weak issue. There is another weird problem that has happened to many of the controllers, where somehow the controller is powered from DC-DC, that is powered from the AC line that has a very small rectifier. And there is a failure mode whereby the charger tries to start charging through that small rectifier instead of through his own big rectifier. And so that blows that little rectifier sky high. So one of the mods that you see in most US electric cars that still survive is to add a couple 1 amp fuses in line, just so that if the charger does that, then the fuses blow and not the controller.
Won't the expensive parts blow to save the fuse?
Yeah, actually it's not that expensive. It's just a standard, 1 amp or so bridge rectifier. But it is mounted on the board, and usually the charging current is not that high. So usually the board traces are the ones that are the weakest link and burn off the board, and that is the biggest problem. So that's why you want those 1 amp fuses to blow.
Yeah.
And not the board traces.
On a related note, the Xantrax guys that make RV inverters, they designed some nice stuff. I had a wiring issue in my garage where I was using a 240 volt outlet, replaced the plug on it for my dad to a 30 amp RV outlet, forgetting that the RV outlet is 120 and not 240. And the only thing that blew in the entire RV was a tiny little slow glow fuse in the Xantrax inverter.
Okay. That's very good that Xantrax can take 240 and only blow.
I don't think they would advertise that it can do that, but we were very lucky.
Well, you verified that.
And there's a guy in San Diego who will do component replacement or repair on those units if you're not so lucky.
I have a question.
Okay, go ahead.
So if you parallel two lead packs, are there any adverse effects? Because usually they work by themselves. If you now have these two low resistance voltages and if there's any differential, that you have Are you concerned about that?
Yeah, so the question is if you parallel to leaf packs, are there any adverse things that might happen with the two low impedance packs that you connect together? Yeah, I was aware of that if you have two batteries and they're at different states of charge and you connect them together, one will dump into the other. Yeah, that is a known effect. So I made sure that they were pretty close in voltage. Each leaf pack, I believe, has a 0.1 ohms internal resistance. So even if they are 5 or 10 volts different in state of charge, there is not much problem if you connect them the two in parallel. It's only a few tenths, a few dozens of amps that will run until they're at the same voltage and will taper off. If they're very much different, I mean more than 50 volts, yeah, then you might come into the realm of blowing the fuse in the pack. Yeah. Good. Okay, any more questions about the vehicle or the application of the leaf packs? Then I would like to switch over to the other presentation, and I actually have some Nissan Leaf convenience chargers here. There are two variants, so I'll try to explain what I did to each one of them. You see, if you open the trunk of a Leaf, what you might see inside if somebody just threw the charger from the front yard into the back of the vehicle. This is the older version of a charger.
The 12 amp one. Well,
Yeah, they're all
that one came in
12
and 16.
Oh yeah, this is not the 2018 Leaf now has a 30 amp 240 volt convenience charger.
Right.
As option, I believe. I'm not sure if it comes with every vehicle, or depends on the level, the variant of vehicle that you have. But yeah, this is the. Let me see, can I go here? Right. Set this to full screen. Where's my cursor? There it is. Okay. And then, yeah, there. So this is a view of the charger, backside of the charger. This is slightly wider bodied than the newer variant. I believe this came with the 2011-2012 Leaf, and somewhere during that run they switched to a narrow body convenience charger that I'll deal with later, because they are quite different inside. The tools that you see next to this is how to open the charger. I use a simple cordless drill with a drill bit that is slightly thinner than the screw that you see next to it, so that I can actually make a hole in one of the six, in each of the six corks, that is plastic corks that is sitting in the back, and then pull them out with the screw. So here you see the last of the six corks with the screw inserted, and in background the pliers to pull it out. When you open it, you see this, with the AC port coming in the top, and that's also where you see the problem, that it has a real transformer. And so it only does 110 volts, otherwise you blow that transformer. The rest of the charger runs off of the voltage coming out of the transformer, so you can easily convert it by changing that little transformer in there for a little switching power supply. So here I laid out a tiny switching power supply, actually visible here. I did this last night, so I have all the components still at hand. And so replace this for the transformer. All the electronics work off of the voltage that comes out here. It must be somewhere in the 20 volt area according to what the transformer is supplying. And the Input cord does not need to be changed because these two wires go only to the primary side of the transformer, and they go to the two AC relays that power the output of the charger. And so simply plugging in a 240 volt is not a problem for this device, except this one little MOV that is spec'd for a peak voltage of 270. So if you apply 240 AC, that MOV will blow, so you have to remove that MOV. That's the only real modification that you need to do in order to...
MOV?
Oh, that's a metal oxide resistor, and that's a surge suppressor.
You can connect two in series if you find another one.
If you find another one, yes, then you can connect two in series, and that's what some people do. Although this board is potted, so you cannot read the board. It's potted all, including the bottom of the component. So you cannot really reach the connection. So if you do mount another MOV, simply wire it across the input AC.
Is that basically what Phil did when he did his upgrades, or did you ever look at one of his?
I never opened one of his. I understood that he actually modified the current capabilities.
Yeah.
So you could turn it down and turn it up. And so he did something else as well. He actually reverse engineered the circuit apparently.
Yeah.
On the other, we get to that in a minute. The other one, I think it might be possible to turn it down. Because let me switch. Yeah, so this is the narrow-bodied one. This is the other one that came with early leaves. You see no transformer in here. Everything is directly plugged into the board, and it has a DC-DC. And as you can see, there is a little capacitor sitting here, and you can read the voltage of the capacitor, and it says 200 volts. And that is the reason that this guy cannot do more than 110. So yeah, they made this dedicated to run on 110. Well, of course, the solution is relatively simple, and that is keep it on 110. When you plug into an RV outlet, you have 110 plus 110. So the idea is power the electronics of the charger from the 110 leg and still apply the neutral to the input to the electronics, and cut the wire that goes to the output relays and apply the two phases to the output relays so that the charger itself works on 110, measures the current as 12 amps, but delivers 240 at 12 amps.
But now that means a 240 outlet with a neutral in it, which many people ignore.
And so you must have an outlet with neutral indeed.
Yeah.
Here a close-up on the inlet actually has 5 wires, which is weird. And so I opened it up and cut the cord and the plug, and then found a little glass pearl thermistor inside the plug. And that is the protection that is on this charger, that when the plug heats up, it throttles back. And that might be a clue as to how you can make a charger that throttles back from 12 amps. And so I replaced it with a fixed resistor. Oh, here you see the open plug. And here you can see, I believe, a 24 kilo ohm resistor instead of the glass pearl connected across those wires. And you might recognize the 2 phases, the black here and red here, neutral and ground of a standard dryer cord that I had to modify a little bit in order to fit under these screws. And once mounted, it looks like this, with the second phase going into a heat shrink and going directly to the output that is not visible here, output relay. Let me see there is no modification necessary since the electronics work still on the 110, so there are no MOVs that get too high voltage. It's just the thermal resistor that you need to trick. So that is the two different modifications. You see the familiar dryer outlet plug that is connected to that guy.
Is that a 1430?
Correct. 1430, yes. Although you can...
You could hack the ground lug on it to do 1450 too.
You mean this?
Yeah, that.
You need the ground, so, sorry, you need the neutral.
Yeah.
So you cannot cut the neutral off, but
shape the handle off of it.
you can trim it until it fits in both 30 and 50 outlets. Yeah. This is the other trick. And that concludes the presentation about the modifications I did to the two variants of the Nissan Leaf convenience charger. And especially the early Leafs, the 11 and 12 that I had for almost 2 years, they charge at 3 kilowatt. And if you provide 240 to them at 12 amps, the limit that the convenience charger will allow, it's almost 3 kilowatt. So you're almost charging at full speed with those vehicles. So the convenience charger is actually a very convenient way, and I've used it for over a year to charge that Leaf at the maximum speed.
I used mine for years like that, and then when we finally disconnected it, mine had an L620 on it, and there was actually some signs of overheating and discoloration on one of the pins in there, so I guess it was...
Yeah, I found indeed that the 15 amp and so also the 20 amp, because typically it has the same internal guts for the outlets. They tend to run quite hot if you pull 12 amps for hours at the end. Yeah. So I've had discoloration on cords that I made where the cord was actually the right wiring size, so the cord did warm up. But it is the contact resistance in the connectors that gets you after a while, because after plugging in hundreds of times, it's not the nice clean copper on copper, but there is always some grit and some oxidation and some other stuff that gets in, or it gets bent a little bit, so it contacts only the point instead of in a nice flat area.
Yeah.
So yeah, typically what heats up, and that is, every EVer should know, that from time to time, after charging for a while, you just walk by, and instead of only looking at the blinking lights, you also feel the connectors. Is there anything that gets hot?
I used to own a boat which was plugged into shore power with 30 amp 120 volt outlet. And the weak point of that was the contacts on it, because this post was sitting there exposed to salt
water,
rain.
yeah.
And one time it got so hot it almost caught fire.
Yeah, so what is being said is the weak point is usually the outlet that is sitting there in weather and sometimes salt and so gets oxidized. It's not only the cord that you bring, but also where you plug into. I recall that at one point in time, I think it was the police who were buying EVs, and for a while they were not using those EVs because somebody had taken their EV home, plugged into an outlet that on the outside of the house that was not used in years, and the outlet burned up. And so they were so shocked by the fact that you would do that with just plugging in an electric vehicle that they said no more electric vehicles for a while. Yeah, so sometimes you just need to apply some common sense.
I think that's a big problem with a lot of the 120 volt convenience chargers. A lot of people end up drawing more power than they've ever drawn through some old outlet in a garage that's got loose wires and so forth. So I always recommend people have somebody come out and put a real 240 volt outlet in and just go with level 2 charging with a new outlet.
Yeah, so the comment is that it is a real problem with older outlets, and I find it also that it's a good tester of the quality of an outlet is whether you can charge an EV off of it, and if you doubt whether it does that, just like when you have years and years old faucet sitting there, before you pull drinking water from it, you test it first if it works and delivers something clean to you, or just some spits out some rusty water from the line that has been sitting there rotting for years.
You might also recommend that anytime you're, like say, you're putting in a new electric car or something, you're gonna pull a lot of power, just replace the 120 volt, the receptacle with a hospital grade receptacle, or one of the, the ones that cost you $3 rather than the ones at 79 cents.
Right.
Full 20 amp.
Yeah, those are much higher, much better construction inside.
So the comment is if you want to plug in to a place where you had not plugged in for a long time, consider just replacing the outlet before plugging in, just to make sure that the contact resistance is as you expected.
Another thing you might do is bring an emery board along when you're going to charge, and you just slide it in and out of the socket. Make sure it's insulated.
Those contacts.